Welcome back to Basic Biomechanics. Today, our discussion and video will be on momentum and the properties and equations surrounding this. What is momentum? In physics and biomechanics, momentum is referred to as mass in motion. To work out an object's momentum, we simply multiply the object's mass by its velocity. Momentum is depicted as a lowercase letter p. Therefore, momentum, which is equal to mass times velocity, is P equals m times v. A change in a body's momentum may be caused by either a change in the body's mass or a change in its velocity. In most human movement situations, changes in momentum result from changes in velocity. Units of momentum are units of mass multiplied by units of velocity, expressed in terms of kilograms, meters per second. Because velocity is a vector quantity, momentum is also a vector quantity and is subject to the rules of vector composition and resolution. Here you will see the mass of the ball at 0.45 of a kilogram travelling at 8 meters per second. Times those together to receive your 3.6 kilograms meters per second. A bus or truck has a large momentum. It takes a large or prolonged force to get the truck up to this speed, and it takes a large or prolonged force to bring it to a stop afterwards. With the equation stating that momentum is equal to mass times velocity, if mass or velocity increases, then the momentum will also increase. When a head-on collision between two objects occurs, there is a tendency for both objects to continue moving in the direction of motion originally possessed by the object with the greatest momentum. Because momentum has a direction, it can be used to predict the resulting direction of objects after they collide, as well as their speeds. A Newton's cradle, named after Sir Isaac Newton, is a device that demonstrates conservation of momentum and energy via a series of swinging spheres. When one ball is lifted and then dropped, it produces momentum. After colliding with the second ball in the cradle, kinetic energy is passed through to the last sphere, which gains the momentum from the original sphere. This is attributed to Newton's first law, stating that, in the absence of external forces, total momentum will remain constant. When external forces do act, they change the momentum present in a system predictably. Changes in momentum depend not only on the magnitude of the acting external forces, but also on the length of time over which each force acts. The product of force and time is known as impulse. The relationship between impulse and momentum is derived from Newton's second law, which states that the vector sum of the forces on an object is equal to the mass of that object multiplied by acceleration of the object. F equals m times a. A larger force takes less time to change momentum, whereas a longer period of time decreases the amount of force needed to be applied. This can be seen with crumple zones on cars. The larger the crumple zone, the greater the time for force to be decreased before reaching the occupant. So after watching this video, you should be able to understand 4 points regarding momentum. What is momentum? Collision? Change in momentum? And how does force relate to momentum? Thank you for watching. We'll see you in the next episode of Basic Biomechanics.